Hi, everyone. This is the project I have been working on in my internship program in data science with Saiketsystems. So the project title is Customer Churn Analysis and Prediction. So the goal here is to analyze customer churn in telecommunication company and build predictive models to identify customers at risk of leaving the company and ultimately provide actionable insights and recommendations to reduce churn and improve customer retention. So I worked on this project task by task on a separate files. So I have 4 files. So now we're at task 1. I will walk you through all the steps one by one. So for task 1, I prepared the data, basically data preparation. Prepare the data to support model development, training, evaluation, and generation of actionable retention insights. The objective of this task is to prepare and clean the data for machine learning analysis. The data preparation process includes loading the data set and exploring its structure and contents, identifying and handling data quality issues such as missing values, transforming categorical variables into numerical variables because machine learning only works with numericals, separating customer characteristics from the churn outcome, separating the predictor variable, basically, or the features from the target variable. And in this case, the target variable is churn yes, basically. And splitting the data set into training and testing data. This is very important. And then the prepared data set will be used to develop predictive models capable of identifying customers at high risk of churn and support customer retention strategy. So the first thing I did was imported required libraries. I imported pandas, NumPy, and sklearn. This one is for splitting the data. And then I loaded the telecommunication customer churn data using pd.read CSV file. So this is the path or to the file. This file provided by Saiketsystems. So then I conducted an initial exploration of the data, evaluate data structure and quality before performing data cleaning, okay? So I use data frame.head function to display the 5 first rows of the data frame, as we can see here. This is how our data look like. Then I use df.tail to display the last 5 rows. Then check data dimension, dataset dimension, using data frame.shape. So we have 7,043 records or rows and 21 columns. And here I did some interpretation of the dataset dimension, of course. So there are 7,043 customer records or rows, like I said, and 21 columns. And then you want to see the name of the columns. So view column names. This identifies all available customer attributes, include customer demographics, etc., and the churn. So I use data frame columns, and the names or the title of all the columns are here. Customer ID, gender, senior citizen, partner, etc. We have 21 columns, and I can see churn here, the churn column. And now here, I want some information about the data. So display dataset information, give me a quick summary of the entire data frame, examine the dataset structure. We can even see the data type, etc. Using data frame.info, I can print this. This is the outcome. And here you can see we have 21 columns, 7,043 entries or rows. You can see the name of the columns. displayed all the 21 because start from 0. And that this is how many records we have for each. And I can see that there's no missing data, but I still need to check later. And here, data type, I can see object, etc. So from then object is text, integer 64, or if there is a float, we will see that's numerical. From the first glimpse here, yeah, I have a float here. I can see total charges is numerical, but it is displayed as object. That means we need to take care of that. Maybe later we need to remove that, not to remove, but to convert numerical, convert a categorical variable to numerical. Yeah, so here data frame describe, this will give you some statistics, like the mean, the standard deviation, the minimum, the maximum of the values in each column. Also, the percentage, maybe here for churn, the percentage of people churning, 55, not churning, staying, tuner, because we're talking about tuner, 75%. A tuner here give you 25% tuner, etc. So it gives you a glimpse of the statistics of the data. It provides numerical summaries for senior citizen status, customer tuner, monthly charges, and some useful statistics such as mean customer, tuners, minimum and maximum charge, and customer distribution. This is customer distribution, 25, 50, 75%, how the customer distributed. So understanding tuner and billing distribution help identify characteristics associated with customer retention and churn behavior. That's why these statistics are useful. We can learn a lot from that. And then step 4, I checked for the missing values using data frame that is null.sum. Here I check for the missing values. It says 0, but I will not trust that. I will still double check. I will still do some. Here it's correct. I trust it. But after removing some data or converting some data that's not the right data type, we will check again. So we saw that total charges are displayed as object, which is text, sorry, categorical variable that we call it. So I need to convert that to numerical. To do that, we're going to create a new total charge column. PD that to numerical will convert the total charges into numerical. And after converting, we're gonna check again for missing data. And as you can see, we have 11 missing data in total charges. That we need to take care of that later. So step 5, handling missing data. Missing numerical values are replaced using the median of that column. So calculate the median of that column first, and then replace every NAA or missing NAN or missing value in that column, in that cell, replace it with median. And for missing categorical variable or values, replaced by using the mode. And with this code here, numerical variables first, so identify and select the numerical column first. Here with this code here, select data type numerical, and then loop through the column and replace, fill NA, replace every missing data with median. We use the median instead of the mean because of the type of our data. And then categorical variable, we identify and select categorical columns first, and then loop again through all the lines in the column and check for missing data and fill in the missing data with mode. And then verify again if there is any missing data with data frame that is null, that sum. And we can see total charges. Now it's 0. It says 0, so it's fixed. So remove unnecessary variables. Also, this is also part of cleaning the data. So we know customer ID, it's not needed for learning, for machine learning algorithm training and stuff. So it's just an identifier. So we need to remove it. To do that, we can check first if it's there, then remove it. We can just remove it directly because we know it's there, but the good approach, if you are not sure if it's there, check first if customer ID it's in the column, and then columns, then drop it, basically remove it. And then step 7, convert categorical variable into numerical variable. So machine learning algorithms require numerical inputs. One hat encoding is used because telecommunication category variables is our data set, and they are nominal categories, have no order. So to convert to a categorical variables to binary 0, 1 columns, we use one hat encoding. So with this code here, dummies, get dummies, convert all categorical variable into numerical binary column, 0, 1 columns using one hat encoding method. And then I'm going to separate the features and the target variable. So after one hat encoding, our target variable is churn yes. So to separate the features from the target, we are going to basically create two different data sets. One is X, one is Y. So X data set will contain all the features except for churn yes. The Y data set will contain only churn yes. And then we're going to split data into training and testing data set. We're going to use 80% training data used to teaching the model and 20% testing data to evaluate the model performance on unseen data. To do that, we use X-train, you use train test split. So we define X-train, X test, Y train, Y test, which is with this set, we're going to get the values and we're going to split. First, we're going to split test size with 20% and use random 42. With this code, we're going to split the data to 20% testing, 80% training. Now we're going to verify the split. We can display the dimension of each split. So train features X train, and then how many features we have. And then test features is X test and that shape, which will display the rows and the columns. So as we can see here, train features for X, we have 5,634 rows and 30 columns. For testing feature X test, we have also 30 column for training, because you remember we have in X we have 30 features, but in Y data we only have one. That's why you don't see anything in columns here. It's only one data. It's a churn yes variable. So we only see the records, the rows. So at this point, the data is prepared and ready for machine learning model to answer some business questions. But to do that, we need to do some data analysis, exploratory data analysis, and we need to segment customer, etc., which we'll see in the next step. So to do that, I need to open a new file, task 2. So let's let me open task 2. If I can open it from here. Open a notebook. I have all my tasks saved. So task 2. Yes, this is task 2. Let's see if the data set is uploaded. If not, we need to upload it. Give it a minute. We can see we don't have the data, so I need to bring it back. This is the data. And then it's okay. And then I'm going to copy the path because I need to update my data here. Give me 1 second. This is the right file. So now I'm going to run all to show you the outcome of my code. All right, there's one error here I need to fix first. All right. Then I'll run all to make sure everything is running smoothly. So in this step 2, like I said before, we're going to do exploratory data analysis. So we're going to calculate and visually represent the overall churn rate, explore customer distribution by gender, partner status, and dependent status, analyze churn distribution and its relation with churn, investigate how churn varies across different contracts types and payment methods. So the goal of exploratory data analysis is to understand the data, identify patterns and trends, and discover factors that influence customer churn. The ultimate goal is to gain insight that will guide customer segmentation and machine learning model development, and also business recommendation that can help the company retain more customers. This step can answer some questions like, are certain customer group more likely to leave? Does customer loyalty tuner affect the churn? Which contract type have the highest churn? Which payment method are associated with higher churn? So maybe the company can make some adjustment to retain more clients. So step 1 in this second task, import visualization libraries. Since I work on different files, I imported other libraries. I imported pandas and numpy, the Python libraries, and also the plotting libraries or the visualization libraries, the charting libraries. Then I imported the data also, read CSV. And then calculate and visually represent the overall churn rate. Here I calculated first the churn rate. So I created this variable called churn rate. Data frame churn, I selected, so select first the column churn, then make the count all the values. And then, of course, times 100, this will give you the percentage. So once this print churn rate, we can see no churn is 73%, yes churn is 26%. And then visualization, I use Seaborn and bar chart. With this code, we can see the outcome. We can see no churn is higher than yes churn, which is a little bit good, but still bad for the company, losing 26% of its customers. So the company should do something about it. So most customers remain active, but approximately 1/4 of customers leave. So step 4, we explore customer distribution by gender, partner status, and dependent status. Analyze the distribution of customers by demographic characteristics. So customer distribution by gender, does churn differ from male to female? I did partner status analysis. Are customers with partners less likely to churn? Dependent status, do customers with dependents behave differently, etc. So first, customer distribution by gender. So again, here I just did some charting, the bar chart with this code. So we want to study the customer distribution by gender. How does the churn differ by gender? And this will give you some bar chart like this. So this is the legend. So the blue is no churn, and I would say brown is yes churn. So we see female, this is no churn, yes churn. Male, no churn, yes churn. We can see that it's the same. So our conclusion will be like the gender does not affect churn since it's the same. So interpretation of the bar chart above, churn distribution by gender. Churn rate appears similar across genders, suggesting that gender is not a strong churn drive. It doesn't affect it. And then we can just we're going to study partner status. We're going to do partner status analysis and how it affects churn. Is it the churn different if the customer has partner or no? So again here, customer with partner. Customer partner status. Customer with partner, this churn is small. Customer with no partner, the churn is higher. So customer without partners may have high churn because of one income or few household dependencies, etc. Maybe they live by themselves. Maybe they live with someone who has the membership, etc. So we see people with no partner churn more. They leave the company more. And then we're going to study dependent status, and we're going to do dependent status analysis and study how customer with dependents and the churn, like how does that affect churn? Do they churn more if they have dependents or they churn less? We will see. So with this code, I displayed the graph here, the bar chart here. So we can see customer with dependent status, they churn less. Customer without dependents, they churn more. So the findings, customer without dependents have a higher churn. They are a high risk of churning. Okay. So step 5, we did analyze tuner distribution and its relation with churn. So how are customers distributed according to the number of months they have been with the company? You can study how long customers stay with the company. So tuner relation with churn, do customers with shorter churn more, or do customers with longer tuner churn more? Do customers with shorter tuner churn more? We will see. So here, tuner.describe will give me some statistics about tuner. So we have the mean, the standard deviation, the minimum, maximum, and the type of data is flowed. So these are some statistics about the churn. About the tuner, sorry, how long they stay with the company. So 75% of customers stay the company, 55%, sorry, they stay with the company, and 26% leave, right? So we're going to visualize that to understand more using this code, using an histogram this time. We can see the new tuners, the people who stayed just like few months, they churn more. You see how high is this first bar here? They churn more than the long-term committed customers. So many new customers churn, few very long-term customers. So tuner relationship with churn. Now, here just show distribution of the customer distribution, tuner distribution. We can see we have the company has a lot of new customer than long-term tuners. So here now we're going to study tuner relationship with churn. With this bar here, the box plot will show the tuner relationship with churn, tuner distribution by churn status. So people no churn, like customer with no churn, they have higher median. Like churn customers have lower median tuner. These are the tuner customers. They have lower median tuner. Like they are the new customer who churn. The churner customers, they have a higher median tuner, means they stayed with the company longer. They have longer commitment. That's what it means. So churned customer have lower median tuner and stayed customer have higher median tuner. So customers with shorter relationship with the company tend to have a high churn risk. So business should consider retention of new customer strategies. Step 6, we're going to investigate how churn vary across different contract type and payment methods. So analyze how customer contract types influence churn. Does contract length affect churn? Analyze customer churn by payment method. So as we can see in this plotting again, the bar chart, we can see month-to-month contract type customer churn more. So the contract type does affect the churn. So month-to-month contracts have the highest churn. Longer contract improve customer retention because they create stronger commitment. So companies should consider improving retention by offering incentive to promote longer contracts. Since month-to-month contract have the highest churn risk, so let's investigate further and see how monthly charges relate to churn. So here with this plotting, box plot, we can see people who churn have higher monthly charges, which is bad for the company. People who don't churn have lower monthly charges. You can see it's slightly higher here. So churned customers have slightly higher monthly charges. So the company is losing its high value customer. So analyze customer churn by payment method in this bar chart with this code. We can see electronic check payment method churn higher because this is churn. So the payment method does affect churn. So electronic check customers often show higher churn. So the conclusion here, summary of key findings. Overall, approximately 1/4 of customers have churned. Customers without partners and those without dependents exhibit higher churn rate. Additionally, customers with shorter tenure, month-to-month contract type, high monthly charges, and those who use electronic checks as their payment method are more likely to churn. So business insights and some recommendations here. These findings suggest that newer customers and those with less stable service agreements represent the highest risk group and should be prioritized for targeted retention strategies. Companies should encourage month-to-month customers to switch to long-term contract, develop retention campaigns for new customers with short tuners, maybe offer incentives or bundle to save, something like that. Promote automatic payment method associated with lower churn. Target high-risk customer groups with personalized offers. So this is it for step 2. Now we're going to go to step 3. Again, let's open the notebook. Step 3. We find it. Step 3, we're going to do customer segmentation. Let me just find it. Task 3. Okay, I see it, this one. So let me open the file, give it some time. Again, check if the data is there. So I'm going to remove task 2 because we're done with task 2. And then I'm going to check if data is here. It's not there, so we need to upload the data first, the data file, the CSV file. And then copy the path again. Need to update my data because I used a different file earlier, just testing my code. So here, and then run all. All right. So in this task, customer segmentation and churn risk analysis. The objective is to group customer into meaningful segments based on their characteristics, identify which segments have the highest churn rate, and pinpoint high-value customers who are at risk of leaving. These insights help the company develop target retention strategies. So to do, we segment customers first based on tuner, monthly charges, and contract types, because we have seen before in task 2 that these have more impact on churn. These three features: tuner, monthly charges, and contract type. And then analyze churn rate within each customer segment. Now, then second, identify high-value customer who are at risk of churning and may need special attention. Which type of customer are most likely to churn or to leave the company, and which high-value customer require intervention. Remember, the high-value customer are the customer who pay more, generate more revenue for the company. So they need to be prioritized. Import required the library first, like I did before, because I work in separate files, so I need to import everything first. The libraries, and then the data file, read CSV. And then this time I will create a working copy of the data set, so I will not change the original data. I will have another copy for segmentation. Data frame segmentation copy. This is the code that will get me the copy. And then segment customer by tuner and calculate the churn rate for each tuner group. To segment customer by tuner, first I create another column called tuner group with my data frame, segmented data frame, using this cut. And I specify here bins, the interval of my group, what interval to use to create the groups. So for the new, then I labeled the groups. The new customer are the customer who stayed 0 to 12 months. Mid-term customer are the customers who stayed 13 to 36 months. Long-term customers, 37 months are up and up. Then I calculate the churn like I did before. A group by tuner group. I use lambda function here to calculate the mean and then the rate, and apply means to apply this to every group. So group by will give me all the groups, the new tuner, mid-term, long-term, and mid-term, new mid-term and long-term groups, and then apply this function, this expression on every group to calculate the rate, the churn rate for every tuner group. And then here did some visualization like I did before with bar plotting. Like we say, the new tuners, they churn more. They have a higher churn rate. So new tuner group have the highest churn rate. The new customers are more likely to leave the company. So the company should improve first-year experience for the customers, engage more with their customers before they leave, and onboarding incentive, offer onboarding incentive to maintain customers longer. Step 3, I will segment customer by monthly charges and then calculate the churn rate again. So to do that, I use the QCAT to give like how many groups I want. I want 3. I label the groups low value, medium value, high value customer. And then here I calculated the churn again using the lambda function and visualize the churn. I can print the charge churn. I can print the percentage, but I also the rate, sorry, I can print the rate based on the charge, but I also can visualize that using the bar chart. We can see a high value customer, the customers who pay more, they have a higher churn. So interpretation, customers with high monthly charges, high value, churn more frequently. So high value customers have high churn, which means the company is losing its most profitable customers and should prioritize retention campaign for these customers. Now in step 4, I will segment customer by contract type and calculate the churn and then also visualize it to see better. So contract churn with the function group by go to this, like select this column contract and find all the groups and then check the churn. And then with lambda, apply this expression to all the groups. If churn yes, or churn based on different contract. So group first and then calculate the churn. Since we already have the groups, the reason I did not use a code to do the groups because the contract or column already grouped by month to month, 1 year, and 2 year. So we only need to calculate the churn rate for each group using group by. And then here, visualization of the churn rate by contract, we can see month to month has the highest rate. So the shorter term contract they churn more. So contract type represent customer commitment. Customers without long-term contracts are significantly more likely to churn. So in step 5, we're going to identify high-value customer at risk of churning. So define criteria for customers who are valuable, but also at risk of churning and may need special retention. The criteria are tuner, new customers, high monthly charges, and month-to-month contract. These are the high risk. Combine the segments to identify high-risk customer. Combine short tuner, high monthly charges, and month-to-month contracts in one column, and then calculate. And then we're going to create first the risk segment with this code. And at the beginning, we're going to label everything in this column low risk. And then we're going to use log. And for every group, tuner group, charge group, contract group, we're going to check in these columns, we're going to check if it's a new customer, check if this condition is true. If this condition is true, then replace low risk with high value, high risk. Check in the charge group, check if if it's a high value customer. If it's a high value customer, then change low risk to high value, high risk, etc. And at the end, what we're gonna get, I can now count customer in each risk segment, right? So with low risk, we have 6,673. This one we're using a value count. A high value, high risk customer, we have 370, which is still high. It's significant for the company. So analyze churn rate of risk segment. We're going to calculate the churn rate for each group in the risk segment, the high and low. As you can see, high value, high risk, they have 74%, low risk have 23%. Now extract high-risk customer. Create a data set containing only high-risk customer. To do that, high-risk customer, data frame segmentation, we're going to create this data set risk segment. From risk segment, we're going to create this data set. High value, high risk. Only high value, high risk. And then we're going to display from high risk customer data set. We use that head to display the 10, maybe the 5. I didn't use anything, so I'm going to just display the 5 first rows. So the 5 first customers, high risk customer, high value, high risk. I mean high risk customer, sorry. Now we're going to prioritize high risk customer to identify top revenue customer at risk of leaving. So sort high-risk customer by monthly charges to identify the highest value customer. Remember, the high-value customer are the customer who pay more monthly. So from the high-risk customer, I'm gonna sort the customer by monthly charges, and then I do ascending equals false, which means from the highest to lowest, and then display 20 of them this time. So that head 20 will give me the 20 high value, high risk customer. And we can check how much they pay monthly. Go to monthly charges. So you see they pay 138, no, 112, 111. This is the high paying customers monthly that are at risk of leaving the company. They churn more. So customer segmentation revealed that churn is concentrated among new customers, customers with month-to-month contracts, and customers with high monthly charges. High-value customers with short tenure and flexible contracts represent the highest risk group. These customers should receive priority attention campaigns and targeted retention strategies such as personalized offers, contract incentives, and proactive customer support because they generate high revenue and are at greatest risk of leaving the company. And here are still some business recommendation again. Assign customer success manager, maybe offer onboarding support and provide loyalty discounts for new high value customer, offer incentives to move to annual contracts and provide bundled services for month-to-month customers, create a VIP retention program, proactively contact customers, offer personalized plan for high revenue customers since the risk of losing the high revenue customers have a high financial impact on the business. So this is it for customer segmentation and task 3. And now I'm going to go to task 4. I'm going to stop this one and open task 4. Let's see if I have task 4. Yeah. Make sure I'm sharing task 4. Let's share again task 4. All right. So yes, now I'm sharing task 4 and I have everything. I have the file and it's running. So we're just going to go ahead and explain the code. Go up here. So task 4 is machine learning modeling. So churn prediction model description. Choose the task or the assignment is to choose suitable machine learning algorithm, logistic regression, decision tree, etc. for churn prediction. Split data into training and testing data set, then train and evaluate multiple models using metrics like accuracy, precision, recall, and F1 score. Perform feature selection and hyperparameter tuning for optimal performance. So the objective is to build machine learning predictive models using the data prepared that predict whether a customer is likely to churn and compare their performance and select the best model for churn prediction. So first, I imported the libraries as always. Since I'm working in different files, I have to import everything again. And also the data file, read CSV file. Then, since I'm working in different file, I have to prepare the data again, just like I did in step one. I did some data cleaning and preparation to make sure that model works better and trains better. So first I convert total charges to numeric, handled missing values, and remove customer ID, and into one-hot encoding to convert categorical variables to numerical variables. So here, this code converted total charges to numerical. This one fell missing numerical values. Since I did that in step one, explained this in step one, I'm just going to go through them. So I fill in missing numerical values, then I fill in missing categorical values, and then I verified if there's any missing values, it says 0. Then I removed customer ID. Then I performed one-hot encoding to convert numerical to, categorical to numerical. Then I verify how many columns I have after one-hot encoding. I can see 30 columns, and also I have churn column here created. That's my target variable. And then I separated features from target by creating, again, two sets of data, X and Y. So X contains all the features, and Y contains only churn the target variable. And then I did split the data to training, 80% training and 20% training. I did all of that in step one, but I have to repeat this in this file to make my code work. And then now the building starts. Now build and train all three baseline models. So the baseline models I used logistic regression, decision tree, random forest. But first I trained the basic line ones. Then I will optimize and fine tune with hyperparameters to find the best estimator. So first creating the model. So create the model, train using fit function, and then predict using predict function, etc. So here, build baseline logistic regression model with this code here, logistic regression, random state 42, maximum iteration 1000. And then here I trained the logistic regression model, like iterate 100 times with X train, Y train using different values, all the possible values in training data set, then make prediction with the best baseline model when selecting after selecting the best estimator, and then you make the prediction with this line of code here. Make prediction with the baseline logistic regression model. Then here I built baseline decision tree again with this code, decision tree classifier. Then I trained the model with the X train, Y train, and then I made the prediction with X test. Here I'm testing the model with unseen data, X test. And here with this code, I built a baseline random forest model and trained the random forest model and then made the prediction. Y. Now step five, where the evaluation start, using metrics like accuracy, precision, recall, and F1 score. So first, evaluate logistic regression model using accuracy, precision, recall, and F1 score metrics. Basically, I just calculated the accuracy score using Y test, Y predict linear regression, the one we calculated before, then precision score, then recall score, then F1 score. Then I printed everything. Here we can see the data. We can see for logistic regression, the accuracy 0.80, precision, recall F1 score is 0.60, etc. And here, then I evaluated decision tree model using accuracy, precision, recall F1 score again. The same thing. I printed everything. And here, evaluation of random forest, same thing. I printed all the matrix in one, you can using that code. And then step 6, compare all 3 baseline model to determine which baseline model performed best and predicted better. So here with this code, and I stored the results in the results. With this code here, I printed everything in one table, as you can see here. All the models, accuracy, precision, recall for each model. And then F1 score is the most informative matrix to select the best model, since it balances precision and recall. This is the information used to decide how to go by selecting which one is the best model. Am I using accuracy, precision, or recall, or F1 score? So in this case, I'm going to use F1 score because we have an unbalanced data set, and F1 score is the best choice in this case. So it predicts how many churners actually churned and how many actual churners the model successfully identified. That's what it means. So to determine which baseline model performs best, I will first sort by F1 score, right? So sort by F1 score to determine which baseline model performed best. Using this code, the results that sort value, this is our data set up there. And then we sort by F1 score. Ascending is equals false means the classification will be from the highest to lowest, and the best baseline model that has the highest F1 score is logistic regression. Remember, this is just the baseline. We're not talking about the best estimator yet. We will find that one later. So logistic regression has the highest F1 score. Therefore, it is the best baseline model for churn prediction. Now, step 7, I will perform feature selection. We will to check which features have impact, to have importance to determine on the prediction of churning. So which features, which attributes, which variables contribute the most to prediction. So feature selection. So feature importance. This is the code I used, and I stored that in feature importance. And then here I printed the first 10 features that have impact on the prediction. And also I plotted those. So we're using the chart bar plotting to produce the chart bar. So we can see here all 10 features that have impact. You can see total charges, tuner, monthly charges are have more impact on the prediction. So these top 10 important features contribute most to churn prediction. Then the next step should be to remove the features with importance below the threshold, like the weak impact, and retain only all models using and retrain all models using only the selected features, the more important features. Then compare performance of the models before and after feature selection. However, and given that churn data is not a high dimension data, we only have 30 features, and also the models automatically select the importance. So for random forest, for instance, it ignores less useful features. For logistic regression, it reduces the influence of the weak predictors. In case of decision tree, you have choose informative features when splitting by default. You have the default feature. So therefore, retraining using only important features won't change much of the performance of our model, given our data set. So for that reason, I will keep all features and proceed with tuning all 3 models, compare the tuned models, and choose the best model. So here I will perform hyperparameter tuning of all the models, all 3 models: logistic regression, decision tree, and random forest. Let's start with logistic regression. So here I selected or I identified the hyperparameters that I will use for testing, for trying the model. And here I wrote my logic. I constructed or created the grid search CV. And here where I train the model, basically how this works, this is where everything happened. So basically it will select, it will follow these steps, try the different models, performing the multiple like iteration, like 1000 iteration, 5 cross-validation folds, trying different all possible combinations of the hyperparameters and calculating F1 score each time, and then selecting which one is the best F1 score, cross-validation more higher F1 score, and then that's the model, that's the best model. And then with that, we can print best parameters that contributed to that best model. We can print best F1 score, which you will see, I think it's printed. Yeah, the best parameters are C, 0, 1, class weight, balanced, penalty, 12, solver, linear, and the best of one score is 0, 63. So after selecting the best model, and now I need to recreate the best model, right? So make prediction, use it, no, not before making prediction, I need to retrieve the best model using, call it optimized linear regression, and grid search that best estimator, which we find up here. Because remember, we have estimator here, and then we selected the best estimator, and that's what we use to recreate the model. And then make the prediction with the optimized logistic regression model, and then evaluate by printing all the calculating and printing all the accuracy, precision, recall of one score using the optimized linear regression model. Print everything. And I did the same thing for decision tree. After selecting or identifying hyperparameters, creating the grid search CV, and training the model. Here, train different combinations of the hyperparameters, perform 5 cross-validation forward, selecting the best F1 score, that's the best estimator, and then printing best parameters, best F1 score, and using the best estimator to recreate the model, and then make a prediction with the optimized model, and then also evaluate and print all the metrics. And I did the same thing for random forest. These are the parameters, the hyperparameters that I will train with. And random forest logic, random search CV, and also train the model. So basically here, when train the model test 100 iterations, 5 cross validation folds, but each time randomly select combinations, possible combinations from the hyperparameters, because it's random, and then calculate F1 score each time, and then choose the best F1 score after validation, and that's our best estimator. Then print the best parameters, best F1 score, and here use the best estimator to recreate the model, the optimized random forest model, and then make the prediction and evaluate again and print all the matrix, evaluation matrix, like this. Now, in step 9, we are going to compare all 3 models, all 3 optimized models with this line of code, just like what we did up here with the baseline models, and print everything in one table so we can see better. So random forest, logistic regression, decision tree, and here we have all the evaluation matrix as our column names. And we can, here, since we said we're going to compare by F1 score, you can see which one has the F1 score, but we can use another better option just by sorting. Select the best model. How to select the best model? F1 score is the primary matrix used to select the best model. So here, with this code will print the best model. We can see it here, but we need to print it using code. So best model equal result that lag result of one score ID max model. and then print the best model is best model. And we can see the best model is random forest. So now that we know the random forest model achieved the highest F1 score while maintaining strong precision and recall, since customer churn prediction involves an imbalanced data set, the F1 score provides the best balance between correctly identifying customers who churn and minimizing false alarms. Therefore, the random forest model was selected as the final predictive model. So now that we know which model is the best to use for churn prediction, we're going to interpret feature importance for random forest model, for the best model. So feature importance, what features have impact on the churn prediction using the random forest model? I store that in feature importance and feature and then importance using this code. I will get, then I will print 10 top features that have impact on the model. Then I'm going to visualize using also the plotting, the bar plot, matlib plotting. With this code, I can get this bar plotting to see which features influence the model. We can see tuner, total charge, contract, 2 years, etc. All these first ones impact more, have more impact. These are like a little bit weaker impact, etc. So at this point, our analysis and our model building is done, model selection is done. So to interpret the result, tuner, total charges, contract 2-year and monthly charges have more impact on the prediction. Therefore, short tuner customer with high monthly charges and flexible contract type are more likely to churn. That's our final decision. Business recommendations, which I did before, but I will summarize here. Offer retention discount to customers predicted to churn. Encourage month-to-month customers to switch to long-term contracts. Contact high-risk customers before their contract expires. Improve customer support for new customers during their first year. And provide loyalty rewards to long-term customers. So the summary of our work, all the 4 steps in this churn prediction project. The customer churn data set was prepared through data cleaning, missing value handling, and category call variable encoding. Exploratory data analysis identified important churn patterns related to tuner, contract type, and monthly charges. 3 machine learning models, logistic regression, decision tree, and random forest were trained and optimized using hyperparameter tuning. Model performance was evaluated using accuracy, precision, recall, and F1 score. The best performing model was selected based on its ability to accurately identify customers at risk of churning. Feature importance analysis provided insights into the key drivers of customer churn, and business recommendations were proposed to help improve customer retention. So the conclusion of the project overall, the customer churn analysis successfully identified the primary factors contributing to customer attrition. Machine learning models were developed to predict customers at risk of leaving, with the random forest model providing the strongest predictive performance. By integrating this predictive model to customer retention strategies, the telecommunication company can proactively identify high-risk customers and deliver personalized retention offers. Target intervention focused on new customers, month-to-month subscribers, and customers with high monthly charges have the potential to reduce churn, improved customer satisfaction, and increase long-term revenue. Continuous monitoring and periodic model retraining are recommended to maintain predictive accuracy as customer behavior changes over time. This is it for all the project. It's done. Thank you.